Okay, so before we do law of sines, we're going to look at the tangent graph just really fast on page 246. You should be able to fill in this whole entire chart, so give it a try. I'm focusing on tangent. So you can see the tangent is undefined at pi over 2. So if this is pi over 2 and this is the opposite of pi over 2, we're going to have asymptotes because we're undefined, so the graph is not going to hit there. Now you can see that the tangent of 0 is 0, so we're here. And then if we go to the right by pi over 4, we're going to go up 1. And if we go left, we're going to go down 1. And so the tangent graph looks something, that's not great, but looks something like that. And so the domain of the tangent graph goes from pi over 2 to negative pi over 2 is the domain. We're going to look at the tangent graph really quickly. It's on page 246 before we do law of sines. So the tangent graph, you should be able to fill in this entire chart, but we're going to focus on tangent. The tangent of 0 is 0, so you have a point here. The tangent of pi over 4 is 1. So if I come pi over 4, I'd be up 1. And if I went to negative pi over 4, I'd be down 1. And then you can see that the tangent of pi over 2 is undefined. And so this is going to be an asymptote at pi over 2 and negative pi over 2. And so now we have what our tangent graph looks like. It's going to keep repeating every pi units. So the period from negative pi over 2 to pi over 2 is pi units. So every pi units we repeat. So the period of tangent graph is pi. The range is going to go down forever and up forever. The intercepts are going to be at 0, and that's going to be every pi units. The domain is basically all real numbers except for where these asymptotes are. So there's different ways to write the domain. We could write it as negative infinity to infinity, but x cannot equal pi over 2 plus k pi. So that's one way to write it. The other way to write it would be you could go from negative pi over 2 to positive pi over 2 with parentheses, so not including those, plus k pi for the domain. We know that the tangent is sine x over cosine x. So you can see the zeros of sine are the zeros of the tangent. And the zeros of cosine, because cosine's on the bottom here, are the vertical asymptotes of tangent. And here's what your tangent graph looks like. If I were going to repeat, then I would be here. This would be pi. And then I would get another one of these functions. All right. Now I've skipped to page 255 in your note guide. We're skipping around a little bit to get ready for the ACT, which is coming up. So law of sines. You're going to use the law of sines when you no longer have a right triangle and you want to find all the sides and all the angles of the triangle. So they'll give you some clues of different parts, and then you have to find the rest. So basically, you take the sine of angle A over the side of A equals the sine of angle B over side B. So basically, you have these ratios that you set up as a proportion. Now, you can put the angles on top and the sides on the bottom, or you can do vice versa, okay? And so let me show you how this works. You're going to solve the triangle, meaning finding all the missing sides and all the missing angles. And you're going to have an angle side angle or an angle side. So angle side or angle side angle. Let me show you how this works. So again, we're solving triangles that are no longer right triangles. If I have a right triangle, I'm going to use SOHCAHTOA. So this triangle, it says angle B is 15 degrees. So here's angle B, and it's 15 degrees. And we have angle C is 52 degrees. So up here is 52 degrees. And we have side B. So across from angle B is side B. And side B is 9 units in length. And so do you see how if I were to pair up my B's and my C's, I only have one missing side. So I have 3 of the 4 measurements. So that's what you're going to do. So you're going to do the sine of B over side B equals the sine of C over side C. And then it's really simple. It's just a proportion. So here we go. We're going to solve for C. So the sine of 15 over 9 is equal to the sine of 52 over C. And when you solve these, all you're going to do is just cross multiply. So now I have C sine of 15 is equal to 9 sine of 52. And then we want to get C by itself. So we're going to divide by the sine of 15. And then this just gets thrown into your calculator. You're going to make sure that your calculator is in degrees, okay? And you're going to type in 9 sine of 52 divided by the sine of 15. And that's going to give you side C. So side C ends up being 27.402. Okay, so the next thing we want to do is figure out what angle A is. So just take 180, subtract 15, subtract 52, and you get 113 degrees. And then you can find your side by just setting up your proportion again. So we could do the sine of 15 over its side, 9, is equal to the sine of 113 over A. Cross multiply. So you have A times 15. So A sine of 15 is equal to 9 sine of 113. And then divide by the sine of 15. You're going to throw this into your graphing calculator. You're going to make sure that you're in degree mode. 9 sine of 113 divided by sine of 15 is going to give you 32.009. And I recommend you put it into your calculator and make sure you can get those values. So I just solved this triangle. I figured out what side A was, what side C was, and what angle A was. And I was able to solve all the missing angles and sides. So now I want to show you how you can use the law of sines to solve a side-side angle triangle. So a side-side angle means you have 2 sides that are given and 1 angle that is given. And what happens is we can end up with 2 triangles, 1 triangle, or no triangles. And what happens if this side isn't quite long enough, then we end up with no triangle. If this side ends up being a swinging door, it can swing in or it can swing out. And when it swings in, we end up with an obtuse angle. And when it swings out, we end up with an acute angle. And so we have different possibilities. So this is why it's called the ambiguous case, because we're not quite sure which of these 3 it's going to be. So let me show you how this one works, starting with example number 2. So it says that we have 54 degrees, and then side C is across from 54 is 7, and side A across from angle A is 10. So now I'm going to do the sine of C over C. So the sine of 54 over 7 is equal to the sine of A, we don't know what A is, over 10. Okay, so we're going to go ahead and cross multiply. So that gives us sine of 54 times 10 is equal to 7 sine of A. So you would divide by 7. And then just a reminder, how do I get angle A by itself? I have to take the inverse sine. So how this works is you would have angle A is equal to the inverse sine of this fraction, 10 sine 54 over 7. And what happens when you put that in your calculator is it doesn't work out. You're going to get no solution. So therefore, the answer to this one is no possible triangle. You a case where you're going to end up with actually 2 triangles. So what we have here is we have a side-side angle. Ooh, what happened there? Fix this. Okay, side-side angle. And let's fill in. So angle C is 31 degrees. So this one maybe looks like 31 degrees. That's angle C. Side C across from it is 29. And then B, we don't know angle B, we don't know angle A, but across from angle B is side B, which is 46. And so on this one, we have a side, and an angle, which is the ambiguous case. So let's go ahead and see what we get. So we're going to start with the first triangle. So the first triangle, you have angle A, angle B, angle C, and then side A, side B, and side C. And side angle C is 31, side C is 29, and then side B is 46. So you can see I have 3 of the 4. So I am going to use the law of sines, and I'm going to use B's and C's. So the sine of angle B over 46 is equal to the sine of angle C, which is 31, over 29. You cross multiply. So this is going to give us the sine 29 times the sine of B. So 29 times the sine of angle B is equal to 46 sine of 31. And then you would divide by 29. And then again, anytime you're solving for angle is when you take the inverse sine. So angle B is going to be the inverse sine of this fraction, 46 sine of 31 over 29. Okay, so you're going to throw that into your calculator. Make sure that when you're putting in inverse sine on the TI-84s that you hit second sine, and then I would use the fraction bar and I would use my parentheses. And we're going to get angle B is 54.781. And what's really important here is you want to highlight this because this was the first angle that you found. And this angle happens to be acute. So now to find angle A, just 180, subtract these two, is going to give you 94.219. And you can add the little degree sign on all of these. Okay, and then you're going to use the law of sines again to find angle A, and just to shortcut it, I'll give you what that is. So it's 56.154. And then you always want to do this small, medium, large check. So you would say, okay, here is the smallest angle. This is the smallest side. Check. Here is the medium angle, 54 degrees, and this side is the medium side. Here's the largest angle, and here is the largest side. So right now, I currently have 1 triangle. Now let's see if we have a second triangle. So your second triangle is always going to have the exact same measurements. that were given. So my given was 31 degrees, 29, and then B is 46. Now, what you're going to do here is if that side swings in instead of out, you're going to get the obtuse angle for angle B. So if B is 54, how you find angle B for the second triangle is you would have to take 180 subtract the 54.781. And that's going to be 125.219. And then you would use 180, subtract these two angles, and you're going to get 23.781. And this is pretty good so far because remember that these all have to add up to 180 degrees. So if this angle was already bigger, when you add up to the 180, you would know that you don't have a second triangle. So now you can figure out what angle A is, and how you would do that, or not angle A, side A, is you would do the sine of angle A, which is 23.781, over side A is equal to, and then you can pick either one of these. I'm just going to do the C's, the sine of 31 over 29. And then you would just cross multiply. So you have A sine of 31 is equal to 29 sine of 23.781, and then divide by the sine of 31. So divide by the sine of 31. Those are going to cancel, and A is going to equal 22.705. And I recommend putting that into the calculator to make sure you can get it. And now you can see that I have a smallest check. I have a medium, up here smallest check. This is the medium check and the largest check. And so I actually ended up with two triangles, and this only occurs with a side angle triangle. And this is because it's the ambiguous case. And what happens is you get a swinging door of the triangle, that you end up with two possibilities or two triangles that are going to work out. Sometimes one triangle and sometimes no triangles. Here's an application problem. The angle of elevation is the angle looking up to the top of the mountain. So from eye level, this angle of elevation is 3.5. So here is your angle of elevation up to the top of the mountain. You drove for 13 miles, and then the new angle of elevation ended up being 9 degrees. So the closer you get to the mountain, the more you have to look up to see the top. The question is, how tall is the mountain? So we're looking for that height. Now, we do see that this is a right angle, but we can't use SOHCAHTOA because we don't have enough information yet. So what we're going to do instead is we're going to focus in on this triangle right here first. And so if I can figure out the side of Z, then I could use that to help me figure out the height. So what we'll do here then is we know that theta is going to be supplementary to 9 degrees. So if we take 180 and we subtract 9, then we get 171 degrees. So now I'm going to go ahead and use the law of sines. So theta is 171. So I would say the sine of 171 degrees over, and across from that is side Z, is equal to, and then let's do, I see this 13, right? So what if I use this angle up here, because I know that 13 is across from it. So then I could say the sine of whatever this angle is, and then it would be over 13. So how do you find this angle? You're going to take 180 and you're going to subtract 171, and then you're going to subtract 3.5, and that gives me 5.5. So this angle up here is 5.5, and across from it is 13. So sine of 5.5. There is a decimal there. Okay, so cross multiply. So z sine of 5.5 is equal to 13 sine of 171. Divide by the sine of 5.5. Divide by the sine of 5.5. So now if you take your calculator, you're going to do fraction bar, and then you're going to type in 13 sine of 171, close the parenthesis, over the sine of 5.5. Close the parenthesis, hit enter. And you want to make sure that your calculator is in degree mode, because if you're not in degree mode, then you're going to get something like negative 17.994, but that's not correct. So you have to be in degree mode, and the length of that side is, so Z right here is 21.2179, so 0.218. And I recommend storing that number in your calculator. So I'm going to hit store, and then I'm going to do alpha, and where is Z? Alpha 2 is Z. So I just stored that as letter Z in my calculator. Store is above the on switch. Now what I'm going to do is I am going to look at my right triangle. So here, let's get purple. Here now is my right triangle. And so far I have the opposite side. I have the hypotenuse side, but I don't have the opposite side. The opposite side is what I'm looking for. So sine of 3.5 is equal to opposite over hypotenuse. And you actually want to use this full number from the calculator, not the rounded number, because you really shouldn't round until the very end. So this is going to be great. How I'm going to find h is I'm going to multiply both sides by the 21. So now h is equal to 21.218, full number, sine of 3.5. So on your graphing calculator, you can arrow up and just grab that full number and then hit enter, and then type in sine, and then type in 3.5, close the parenthesis, hit enter, and you're going to get 1.295. So the height of the mountain is 1.295 miles. Nice job. You try on your own, and you're all done.